Today we're going to be looking at section 5.6, which is on finding rational zeros. And our goal is to find all the real zeros of a polynomial function. So the zeros of a function are a number k is a zero of a function if f of k equals 0. So if the remainder is 0, then we know that that's one of the zeros. The constant term is a term that has a number part but no variable. And again, the leading coefficient is the coefficient of the term of the polynomial function that has the greatest exponent. So when we talk about the rational zero theorem, here's what it states. It says if f of x is in standard form, which means it equals a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus on and on and on until we get to a sub 1 times x plus a sub 0. Again, and we've looked at that standard form of any polynomial function before, but if it has integer coefficients, then every rational zero of f has the following form. And here's what they're going to say. It's going to be p divided by q, where p is the factors of the constant term and q are the factors of the leading coefficient. So p is going to be the factors of the constant, that's our numerator. Q is the factors of our leading coefficient, that is our denominator. So when we look at this in example 1, I'm going to simply find those. I'm going to find the factors of p. And remember, p is our constant term, so I want to find the factors of that. Now, we also have to have the plus and minuses. So this is going to be plus and minus 1, plus and minus 2, plus and minus 3, and plus or minus 6. So those are all the factors of my constant, so that's my p. Now q is going to be the factors of my leading coefficient. Well, that's 1, so it's going to be plus or minus 1. So when we look at all of the possible zeros, it is going to be those numbers that are p divided by q. Well, if the leading coefficient is 1, it makes it super easy because it's simply whatever my p is. And so all the possible zeros are right there. And the reason that is because if we take 1 divided by 1, we get 1. 2 divided by 1, we get 2. 3 divided, so if we divide it by 1, it doesn't change anything. So there are my possible zeros. Now, what the possible zeros are going to tell us is what are the possible numbers we should use when we're doing our synthetic division, when we're trying to factor these. So if we look at example B, again, p is going to be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Those are the factors of my constant. And my q, in this case, now the leading coefficient is not 1, it's going to be 2, so I have to find the factors of that. So plus or minus 1 and plus or minus 2. And so now again we go to the possible zeros. And the possible zeros is always going to include the whole list of p's, which is plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Because if I take all of those divided by 1, I get all of those. Now I also have to take them divided by 2. So I have plus or minus 1/2. And then plus or minus 2/2, which is 1. I already have it. Don't need to include it. 4 divided by 2 is 2. Already have that. 8 divided by 2 is 4. Already have that. So here are my possible zeros. Right. So what I would like you to do is do the guided practice questions 1 and 2 using the same method that we just used there. Find your p's, find your q's, and then list the possible zeros. So go ahead and hit pause until you are ready. And here are the answers to the possible rational zeros for guided practice questions 1 and 2. Now, the reason we want to know the possible zeros is so that we can find what the zeros of a function are. So that's going to take us to question number, or to example 2. We want to find the zeros when the leading coefficient is 1. So we're going to find all of the zeros in this problem. Now, what the rational zeros are going to do, or the possible zeros, is it's going to tell us which numbers we should try. So if I have this problem, I want to find all the zeros, which means I want to factor it and solve it. So I know that I have -1, -1, -5, 7, and -35. So I'm going to use synthetic division to find that. Well, in this case, I can try any number I want. However, I do know that the possible zeros, which we just found in the previous examples, are the ones that are going to be the only ones that would work. So I should never try any number that is not one of the possible zeros. So that's what it does. It's gonna make that list of possible numbers smaller so that we can use one of those problems. So you don't necessarily have to make the list of the possible zeros in example 2. But you can to make that smaller. So in this case, it's going to be ±1, ±5, ±7, and ±35. Q is going to be ±1. So we know that the possible zeros, the ones that we should try, it's going to come from that list. So let's try those. If we look at example 1, we want to find out what is one of the zeros. So let's just try a number. Let's try, I know that 1, 5, 7, and 35 are the ones that we should try. So let's try 5. And so if we do that, we're going to get 5. That's going to be 0, 0, 7, 35, 0. Perfect. That one works. So it says find all the zeros. So the zeros are going to be x equals, we know that 5 is one of them. And so this is really going to be x squared plus 7 equals 0. If I solve that for 0, that's the other one, or the other one. So I'm going to have x squared equals -7, and x equals plus or minus the square root of -7, which means x equals plus or minus I square root of 7. So here are the zeros. However, in this case, they're only looking for the real ones. Obviously, that's not a real one. Here are the zeros, but in this case, if they ask just for the real ones, it would be 5. Now, in the book, they're going to ask you for the real zeros, but I want you to find all of them. Okay, so in this case, that would be our real zeros. Would be 5, and all of the zeros would be 5, and then plus or minus I times the square root of 7. So go ahead and do questions 3 and 4. Find all the zeros of the function. So you can hit pause while you do those, and when you are ready, go ahead and hit play. And here are the zeros for number 3. So we look at number 3, and I know that P has factors of 1, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. So those are the numbers that I'm going to try. I found that -3 worked. That's the one I put in, so therefore that's automatically one of my zeros up here. And then I factored what I had left, and I got x equals 6 and 1, and those are my other two. Here I found that 2 worked, and then we factored this down to get 7 and 1 is -1 is my other one, so those are the other 2 zeros to that problem. Now in example 3, we're going to find the zeros when the leading coefficient is not 1. So now we're going to look at a problem where the leading coefficient is not 1. So again, my P values are going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. So that's a lot of them. Okay, and then Q, we're going to have plus or minus 1, plus or minus 3, and plus or minus 9. So my possible zeros would be this entire list, 1, 2, 3, 4, 6, and 12, plus all of them divided by 3 and all of them divided by 9. So I'd have 1/3, 2/3, 3/3 is 1 already out there, 4/3, and then also all of them divided by 9. 1/9, 2/9, 3/9, 4/9. And then we have the other two already in there. So those are the list of numbers that I should use as my possible zeros. Well, I'm going to go 9, 3, negative 30, 6, and 12. And now notice here, this is the x fourth. So if I factor 1 out, I'm going to be down only to x cubed. If that's the case, you're going to have to do synthetic division twice. We always have to get down to an x squared, because then we're going to use the rules that we talked about last chapter on solving quadratic equations. So we always want to get this down to a quadratic. So if it's an x to the fourth, I have to do synthetic division twice to get it down to an x squared. If it would be x to the ninth, I would have to do synthetic division 7 times to get it down to an x squared. All right, so we always want to get it down to an x squared so that we can factor it using, or sorry, solve it using the quadratic formula or factoring or one of the rules that we've talked about in chapter 4. So if we look at this problem, let's try 1. And if we use 1, then we're going to go 9, 9, 27, 27, negative 3, oh, did something wrong here. Let me try that again. Multiplied where I should have added. So if I use 1, this is going to be 9. That's going to be 12, 12, negative 18, negative 12, negative 12, and 0. All right, so 1 is one of my zeros. And we'll go over here, and I'll write it over here, the zeros. I know that x equals 1 is one of them. So I know now that I have to do this again. So let's try another number. And you're kind of just, it's kind of just hit and miss. You're going to have to look at the numbers and take a guess at which one you think might work. So 9, negative 18. This is going to be negative 6. And again, I get 0, so I know that I picked the right one. Now, many a times you're not going to get 0. That means the number that you chose does not work. So you're going to have to go until you get one that works. So negative 2 is one of the zeros. And now that means I have 9x squared minus 6x minus 6 equals 0. I'm going to take a 3 out of here just because it'll make it easier for me to check to see if this factors. And if we look at this, it is not going to factor. So it doesn't factor, so I'm going to use a quadratic formula right away. 2 plus or minus b squared, which is 4, minus 4 times a, which is 3, and c, which is negative 2, over 2 times 3. So this is going to be 2 plus or minus 4 times 3 is 12, times 2 is 24. So that's going to be the square root of 28 over 6, which is 2 plus or minus, that's going to be 2 square roots of 7 over 6. So if we reduce that, we're going to get 1 plus or minus a square root of 7 over 3. And so here are the zeros to that problem. Now, what I would like you to do is go ahead and do the guided practice questions 5 and 6. See if you can find all of the real zeros of those. So go ahead and hit pause until you are finished, and then hit play. And here are the zeros for questions 5 and 6. Notice in number 5, we went down to a quadratic. We were able to factor it. Number 6, we had to use synthetic division twice to get down to a quadratic. Then that quadratic did not factor, so we had to use a quadratic formula to find the answer to that one. Example 4 is on a real-life situation. So he says we have a prism that has a square base. All right, so we're going to draw our prism. And as a square base, so we know that this is x and this is x. And it says the height of that prism is 5 feet longer. So the height is going to be 5 feet longer, which is x plus 5 on each side of the base. The volume of the prism is 28 cubic feet. Now we know that volume of a prism is length times width times height. So it's going to be x times x plus 5 is going to equal 28. Well, this is going to give us x squared plus, or sorry, x cubed plus 5x squared equals 28. Well, if we put it in standard form, we're going to get x cubed plus 5x squared minus 28 equals 0. Okay? We always want to have it in standard form. So now we want to know what is the height of this prism. So let's find it. Well, again, we know we have to use synthetic division. So we're going to set up our problem to do so. We're going to have 1, 5, and again, we don't have the x column, so we have to have a 0 and a negative 28. So now we're going to try to find a number that works. Well, we know that it has to be here, factor of this divided by the factor of that. Well, that's 1, 4, 2, 7, 14, 28. So let's go ahead and try a number. And let's try 2. So if we do that, oh, and that one worked. So we got it. However, we have to try now this plus 7x plus 14 equals 0. So now what we have to do is that's not going to factor. So we have to try to use a quadratic formula. So x equals negative b plus or minus b squared, which is 49 minus 4 times 1 times 14 over 2 times 1. So x equals negative 7 plus or minus the square root of 4 times 14 is 56. So 49 minus 56 is going to be negative 7 over 2. Now, as soon as I get here, I can stop because I know that with this negative number in here, that's going to be an imaginary number. So this is not going to work. None of this will work. So we know that x must be 2. So the question then asks, what is the height of the prism? Well, if x is 2, we know that the height of the prism is 7 feet. Right, so sometimes they'll ask you for the height of that object. Sometimes they'll ask you what are the dimensions of that object. So make sure to go through and answer the question that they ask us, or that they ask you. So again, today we're talking about section 5.6, which was finding the rational zeros. So the first part of the lesson we we used to find out what can we do to find which numbers we should check, find the possible zeros. And then after that, we had to find them. So the only difference between the lesson today and the lesson that we did yesterday is yesterday they gave us some numbers to check. They said, okay, this one is a factor, or this one is a zero, and this one is a solution. Today they didn't give us those. They just said factor it or solve it. So we had to find out which numbers to try to use to do that. So here is your assignment, is on page 374 for section 5.6, which is on finding rational zeros.